This video will be a quick introduction to perfect squares and perfect cubes. So for number 1, we have the square root of 4. Remember that this is asking you what times itself will give you the number under the radical. So we're looking for something times itself to give us 4. So 2 times 2 is 4. This one is a smaller number, and it's probably obvious, but that's what we're looking for. So this one is 2. Number 2, the square root of 9. We're looking for the negative square root of 9. So the square root of 9 is 3, and then we want to bring down or apply that negative. So this will be negative 3. Number 3, square root of 1. 1 times 1 is itself, so that will be 1. Number 4, the square root of negative 16. So if you try 4 times 4, you'll get a positive 16. And you may think, well, what about negative 4? Negative 4 times negative 4 is also a positive 16. The only way to get a negative 16 is by multiplying a 4 and a negative 4. But that is not what squaring means. It means to multiply something by itself. So there is no way to multiply a real number by itself to get a negative. So what we're going to do is we're going to define an imaginary number. So I is equal to the square root of a negative 1. So anytime we have the square root of a negative, we're going to write that as an I. So in this example, this negative would come out as an I, and then we would take the square root of 16. So the square root of 16 is 4, and the square root of a negative is an I, so we would have 4i. Number 5, will this one have an I? Hopefully you see that the answer is no, because the negative is outside of the radical and not under the radical. So we're just going to bring the negative down, and then we're going to take the square root of 196 and 9. So the square root of 196 is 14, and the square root of 9 is 3. So this will be negative 14 over 3. Number 6, will this one have an I? So the negative on the outside of the radical will come down as a negative sign in front. But the negative under the radical will give us an I. So that's going to come out as an I. And then we just take the square root of 1 and the square root of 4. So that'll be 1 over 2. So you can say negative 1/2 I. The I is like big in the middle of the fraction. Or if you want to put it on top, you can do that. This would be my preferred way for you to write it. Just make sure you don't write it where the I is in the denominator, because it's not in the denominator. Okay, number 7, we have a cube root now. So the cube root of 8 means we want to find something that multiplies by itself 3 times to get 8. So this would be 2 times 2 times 2. So the cube root of 8 is 2. Number 8, we want to find something that multiplies by itself 3 times to get negative 64. If you have a cube root, you're multiplying something by itself 3 times. 3 negatives would make another negative. So this is not going to be an I. You only get an I when you have a negative under the square root, not the cube root. So this will be a negative, and in fact it's a 4. 4 times 4 times 4 is 64. So the answer to number 8 is negative 4. All right, number 9, we're going to do the same thing. Notice the negative is on the outside here. It doesn't make a difference for the cube root whether the negative is on the outside or the inside. Either way, you're going to get a negative 4. Number 10, the cube root of 1 is 1. Number 11, we're looking at variables here. So in order to bring that out, remember that we want to figure out what multiplies by itself to get the y squared? The only way to get a y squared is to do y times y. So the answer to this would be y. We're going to be doing the same thing with the next one. So x to the fourth would be x squared times x squared. So x squared is the square root of x to the fourth. Keep in mind that if there's not a number here, this is understood to be a 2. It's a square root. That's a square root. So let's think about how we can split up z to the 16 into two factors. So if we're splitting it up into two factors, we want something times itself to be 16. Well, if you're splitting 16 up into two things, that's 8 and 8. Notice what happens with all of the exponents. So let's go back and look at number 11. Our exponent was 2, our index or root was 2, and we ended up with 1s, right? Our exponent number 12 is 4, our index or root is 2, and we ended up with 2s. So the answer was a 2 exponent. In number 13, our exponent was 16, our index was 2, and we end up with z to the 8th as our answer. So there's a pattern. What we're doing is we're dividing the exponent by the index, the exponent by the root. It works every time. So if you simply divide 16 by 2, you get 8. And that's how you find the exponent. So let's look at number 14. Here we have a coefficient of 4, and we have a variable of x to the 6th. So we can take care of the square root of 4 first. That would be 2. So 2, and then 6 divided by 2 is 3. So that'll be an x cubed. So 2x cubed. Okay, we've got a few more. We have a cube root of x cubed. So this is the same process. You're going to divide exponent divided by index, or exponent divided by root. So your new exponent will be a 1. So x to the first, or just x. Here we have exponent divided by index is 2. So this is going to be y squared. Okay, so exponent divided by index or root gets you your new exponent. Number 17, we have the cube root of 8, that's 2, and then the cube root of z to the 12th. So 12 divided by 3 is 4, so that would be z to the 4th, so 2z to the 4th. The last one, cube root of a negative 64x to the 21st. So this is going to be a negative 4. 21 divided by 3 is 7, so x to the 7th.